Hi, my name is Lelia Glass, and I'm an assistant professor of linguistics at Georgia Institute of Technology. And in this series of 3 videos, I'm going to show you a sociolinguistic data pipeline using DARLA, BedWord, and Praat. And I'll talk about what those tools are. So I made this video originally for students on my research team so that anyone who's new or who missed a day has a resource to go look at to learn how to transcribe sociolinguistic interviews, but I'm making it public because I also want to share it with anyone who wants to learn tools for processing sociophonetic data. Sociophonetics refers to social sounds. So the goal of sociophonetics is to quantify variation or change over time in people's speech or accents by measuring the position of the tongue in the mouth when the person pronounces a vowel. So when you pronounce a vowel, your tongue is either high or low or front or back in your mouth. And that tongue position is actually recorded by the computer as formants F1 and F2. And so we're going to extract measurements of F1 and F2 as a quantitative metric for accents. And then we can do statistics to understand how different people talk. That's kind of the big picture here. So in general, when we do sociophonetics, often what we'll do is we'll record some audio, usually in English, or this presentation is going to focus on English. So we're going to record some audio with a microphone. Then we're going to transcribe it, and then we're going to use both the audio file and the transcription to then measure vowels, measure F1 and F2, the position of the tongue in the mouth when pronouncing the vowel, like I mentioned. And then finally, we're going to analyze the data. So this over here on the right is a vowel plot. Here we have F1 on the y-axis, F2 on the x-axis. They're set up this way in order to actually try to represent the position of the tongue in the mouth, so that this is the top front of your mouth and this is the back bottom of your mouth. So that's why we have the axes set up this way. And basically what this graph is showing us is that in the data that were used to produce this graph, data from my own sociophonetics corpus, we see a big difference in gender for the vowels a and e. So trap and dress, a and e. We see a gender difference where women are pulling these vowels a little lower and backer than men. And that's the type of inference that we would be able to draw when we have a bunch of different data that we've processed in this fashion. So these 2 videos are going to focus on what's in the purple box, the process of transcribing data and measuring vowels. So we have 3 videos today that are going to go through a few different steps. So the first step is not a video. The first step is to record a sociolinguistic interview as a WAV file. I'm not going to talk about that today. I'm going to assume you've already done it. You already have a WAV file on your computer that you want to then extract sociophonetic measurements from. Then the next step is going to be, in this pipeline, to generate a computer-generated draft text grid. And that's what I'm going to talk about in this video. The way we're going to do that is we're going to use a few different tools, including BedWord, which was created by my student Marcus Ma at Georgia Tech. BedWord actually uses Deepgram, which is a state-of-the-art speech-to-text system. And then BedWord and Deepgram are set up in a web interface on the website of DARLA, which was created by James Stanford and Sravna Reddy. So I'm going to talk about all of these tools in this video. And then in the next 2 videos, I'll talk about the subsequent steps. Okay, so in this first video, we're going to show you how to get a computer-generated draft text grid. So first, we're going to start with the interview as a WAV file. Then we're going to send the interview through this pipeline that I talked about that's hosted on DARLA, but that uses both BedWord and Deepgram. And then we're going to receive an email with a computer-generated draft text grid. So I'm going to show you all of that on my own computer right now. So let me actually press escape. I hope I can escape out of this video. I'm going to press escape. And then I am going to head over here to my desktop where I have an interview saved right here. 3495 interview.wave. And then what I'm going to do is I'm going to head over to this website, DARLA, and I'm going to go over here to the home page, and then I'm going to click here on completely automated vowel extraction, and I'll click here, and then I'll click on where it says BedWord, right? Then I'm going to need a few different things. So first I'm going to need my audio file, which is, again, I have this audio file, 3495 interview.wave. I'm going to put that there. Then I have a Deepgram key. You can get your own Deepgram key by clicking the instructions that are linked from this website. The Deepgram key is actually you are paying for Deepgram. You're not paying for DARLA, but you're paying for Deepgram because Deepgram is a state-of-the-art speech-to-text system. So you'll need an API key for Deepgram. Then you're going to upload your interview. Then for this video, we're actually going to leave all of these settings in the default state. So I'm going to leave it as don't try to remove the interview or transcription. I'm doing it that way because that actually usually doesn't work very well, so I'm just not even going to try it. And then I'm going to leave don't include punctuation in the output, and then don't send the results through DARLA. I'm just going to leave that the way it is for this pipeline that I'm showing you right here. Then I'm going to put in my email address and I'm going to click submit. And this is actually going to take a little while now. And that's because this interview is quite big. It's around 35 minutes long. And so it will take a while for it to be uploaded to DARLA and sent through this system. So once you've clicked submit, you might actually have to wait a little while. It also might depend on how good your internet is. I have Google Fiber at home, so it took me about, I would say, 15 minutes for this interview to go through. But depending on your internet, it might be slower or faster. So I'm actually then just going to skip over. I already did this before the video so that I wouldn't have to wait on the video. And so I'll show you what I got here. So here I got an email already from DARLA that says, here's the automated transcription results for your data. We've provided transcriptions in a TextGrid, CSV, text, and EAF without punctuation. So that's the type of email that you're going to receive when you do this. So the most important thing here for us right now, or for this pipeline that I'm showing you, is the TextGrid. So I'm going to download the TextGrid. Everything else you can take a look at it, but I'm not going to show you that right now because I'm just focusing on what you need for this pipeline that I'm showing you. So now you have a TextGrid, and actually that is all you actually need for this video. Receive email with computer-generated draft TextGrid. That is what you have right now. So I'll quickly show you that. Well, actually, no, I won't show you that. I'll just show you that in the next video because the next video is going to show you how to open that TextGrid and the WAV file and post-edit it in Praat. So actually stop this video right here because we got to the end of our goals for this video. Receive email with computer-generated draft TextGrid. So I will stop there and I'll see you in the next video. Thanks.